Hi everybody, welcome back to our maths class. Yesterday we started our new lesson sets. What is sets? Set is a collection of well-defined objects. Set is a collection of well-defined objects. Okay, then we learned two types of set representation. We have to represent sets in two ways, that is roster form or tabular form and set builder form. Roster form or tabular form, or second one set builder form or rule method. Set builder or rule method. Set builder or rule method. Suppose the vowels in English, how to represent in roster form? How to represent in roster form? A is equal to, in bracket, A, E, I, O, U. Within curly bracket, A, E, I, O, U. That is roster form. While writing the roster form, the set A is in capital letter. Then put a bracket. Inside the bracket, small letter. And put comma. A, E, I, O, U, comma. And never repeat the elements. No need to repetition of elements. Okay. And order of the members is not considered. We can write in any order. Again, set builder form. How to represent this vowels in set builder form? Set builder form means it's also a rule method. Just we are writing a rule. A is equal to X, such that X is a vowel. X is a vowel. Okay. X is a vowel. So X is vowel means how many vowels are there? A, E, I, O, U. Okay. X is such that X is a vowel. Okay. This is about sets, roster form and set builder form. And yesterday we already started exercise 6A. Today also we have to continue exercise 6A, remaining questions. Yesterday I gave two homework questions. Exercise 6A, question sub question 3. X element of Z minus 3 less than or equal to X less than 4. So X element of Z. X element of Z means set of integers, and minus 3 less than or equal to X less than 4. Minus 3 less than or equal to means minus 3 is included. Okay. Minus 3 less than or equal to means minus 3 is included. So minus 3, minus 2, minus 1, 0, 1, 2, 3. 4 not included. Okay, 4 is not included. Only minus 3 less than or equal to means minus 3 is included. So minus 3, minus 2, minus 1, 0, 1, 2 and 3. This is set of integers. Integers means negative number, whole number and positive numbers. Okay. The next question, fourth one, A4 is equal to X such that X is a 2-digit number and sum of these digits is X is 7. 2-digit number and this digit sum is 7. So we know that 1 plus 6 is 7. 2 plus 5 is 7. 3 plus 4 7. So we can write the numbers 16. Then 25, 34, 40, 43, 52, 61 and 70. These are the numbers. 2-digit number you know. So starting from 16. Okay. 16, 25, 34, 43, 52, 61 and 70. Okay. Now exercise 6A, first section, sub question 5. A5 is equal to set X such that X is equal to 4 and n element of W n less than 4. This is the condition. This is the rule. So x such that x is equal to 4n, the value of x we want to find. X is equal to 4n and this n is element of w. W means set of whole numbers. Set of whole numbers. Okay, 0, 1, 2, 3, etc. And this n is less than 4. So how many numbers are less than 4? Less than 4 means how many numbers are less than 4? 0, 1, 2, 3. 4 is not included. If it is less than or equal to, then 4 included. Here only less than, so 4 is not included. So W means set of whole numbers. So whole numbers means starting from 0. So less than 4. N can take the values 0, 1, 2 and 3. Okay, n is equal to 0, 1, 2, 3. Now, what happened to this? X is equal to, our set is x. So A5 is equal to set x, you know. So the value of x is equal to 4n. X is equal to 4n. So x is equal to, first give the value 4 into 0, 0. Then 4 into 1, 4. 4 into 2, 8. 4 into 3, 12. We want to find the value of x. X is equal to, the condition is that x is equal to 4n and n belongs to w, that is whole number set. This n is in the set of w, whole number set, and n is always less than 4. So n can take the value 0, 1, 2, 3. But don't write 0, 1, 2, 3 as answer. We want to find x. X is equal to 4n. X is equal to 4n. N is in w and n less than 4. So x is equal to 4n means 4 into 0, 0. Then 4 into 1, 4 into 2, 4 into 3. So the answer is A5 is equal to 0, 4, 8 and 12. 0, 4, 8 and 12. Okay. A5 or x is equal to. X is equal to, both are correct. 0, 4, 8, 12. Okay, because x is equal to 4 and you know. Clear? Next, sixth question. A6 is equal to set x such that x is equal to n by n plus 2, comma, n element of capital N, n greater than 5. So here a condition is that x is equal to n by n plus 2. And what is n? N element of capital N. N means natural numbers. That is minus 2, minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. N means natural numbers. That means it includes negative numbers, 0 and positive numbers. N is always greater than 5. So we should take the number n as greater than 5, means 5 is not included, not 5. Greater than, or if it is greater than or equal to, then no problem, then it is, we can take 5. But greater than 5 means the number above 5. Have to take the number above 5. Okay, so we can take n as 6, 7, 8, 9, 10, etc, etc, etc. There is no limitation. Greater than 5 means there are many numbers greater than 5. So n is equal to, don't take 5, 6, 7, 8, 9, 10, 11, etc, etc, etc. Now substitute the value. X is equal to n, take it as n 6, 6 by 6 plus 2, that is 6 by 8, one value. Again another value, 7 by 7 plus 2 equal to 7 by 9. Okay, x is equal to 8 by 8 plus 2, 10. Okay, so A6 or x is equal to 6 by 8, 7 by 9, 8 by 10. Then if x is equal to 9, 9 by 9 plus 2, 11, etc, etc. Once again we can write A6 is equal to 6 by 8, do the cancellation, 3 2s are 6, 4 2s are 8, 7 by 9, 8 by 10 become 4 by 5, 9 by 11, etc, etc, etc. Okay, don't forget to took this etc, etc, etc. Okay, So this is the answer. Clear? Next, question number 2. Set builder form. Write the following sets in set builder form or rule method form. Second sub question, B2 is equal to set 11, 13, 17, 19. So how to form a rule? Here 11, 13, 17, 19. We know that these numbers are prime numbers. So we can write x such that x is a prime number between 10 and 90. Obviously, these numbers are in between 10 and 20, not 19, 20. Obviously, we know that these numbers are in between 10 and 20, 11, 13, 17, 19, and these are prime numbers. Prime numbers between 10 and 20. X such that x is a prime number between 10 and 20. Otherwise, we can write x such that x is a prime number 11 less than or equal to x less than or equal to 19. That also correct. X is a prime number. Okay, x such that x is a prime number. Comma x 11 less than or equal to x less than or equal to 19. That means 11 and in between 11 and 19 and including 11 and 19. Less than or equal to means starting from 11. Less than or equal to the here 19 means up to 90. 19 is included. Okay. Next, question number 3. B3 is equal to set 1 by 3, 3 by 5, 5 by 7, 7 by 9, 9 by 11, etc. etc. Okay. So, how to do this? See here, this is 1, here 3, here 2, here 5, 5, 7, 7, 9, 9 by 11. Here, if the numerator is 1, denominator is more than 2 more than the given number. Okay. Here 1. Here 1 plus 2 is 3, 2 more than the given number. Suppose here 3, then this new denominator is 3 plus 2, 5, Here 5, then 5 plus 2, 2 more than. The numerator, denominator is 2 more than the denominator. Okay, 2 more than the numerator. Denominator is 2 more than numerator. Denominator is 2 more than numerator. That is, suppose numerator is n. Then what about denominator? N plus 2. N plus 2. And one more thing, this 1, 3, 5, 7, these are odd numbers, So how to write x? Set x such that x is equal to n by n plus 2. Okay, n by n plus 2. Where n is an odd natural number. Odd natural number. Don't take natural number. Natural number means it includes 1, 2, 3, 4, 5, etc. But here only odd natural numbers. Okay. X such that x is equal to n by n plus 2. Where n is, we want to find the value of n also. We write the rule for n. So n is an odd natural number. Okay. Clear? Here 1, here 3. So it is numerator is here, denominator is 2 more than the numerator. That is 1 by 1 plus 2. That is 3. That is n by n plus 2. Okay. Now 6th question. B6 is equal to etc. etc. minus 6 minus 3 0 3 6 etc. etc. So how to make a rule? Here these are multiples of 3. 3, 6, then 9 etc. etc. and here minus 3 minus 6 minus 9 etc. etc. to left side and right side 0 3 6 etc. So these are multiple of 6 3. So we can write 3 into n. Multiple of 3, how to write 3n? 3 into n. N can take the values. All the values n can take. 3 into 1 3, 3 into 0 0, 3 into 2 6, 3 into 3 9, then 3 into -1 -3, 3 into -2 -6, 3 into -3 negative 9. So the value of n is z. N belongs to or n element of z. Z means set of integers, you know. Integers means negative number, 0, positive numbers. Okay, so x such that x is equal to 3n. N belongs to z. Z means set of integers. Set of integers. Okay. Now question number 3, sub question 1 is set 1, 2, 4, 16, 64 equal to x such that x is a factor of 32. Give reason. This is the set 1, 2, 4, 16 and 64. The rule method is x such that x is a factor of 32. Here is x is a factor of 32. X is a factor of 32. What are the factors of 32? 1. So 1 is here. Then 2. 2 is here. Then 4 is factor of 32. And 16 2s are 32. So 16 is also a factor of 32. And what about 64? 64. We know that factors are always less than or equal to the given number. Factors is always less than or equal to given number, that is 32. Factors are always less than or equal to 32 means we learned the properties of factors. 1 is a factor of every number and the given number is a factor of itself. The given number is the factor itself. So 32 is a factor of 32. Okay, the largest factor of 32 is 32. It does not exceed the value 32. Okay, it does not exceed 32. Factor is always less than or equal to 32. Okay, less than or equal to 32. It means the factor does not exceed the value, the given factor. That is here 32. So 64 is not a factor. No. Reason. What is the reason? 64 is not a factor. 32. Factor of 32 because 64 is greater than 32, you know. 64 is a multiple of 32 but not a factor of 32. Already we learned the properties of factors and multiples. Factors means every number has one as factor. Then the given number also another factor. And the factors does not exceed the given value. Then what are the properties of multiples? Multiples means it is starting from the given number. Suppose if the factor multiples of 32 means first multiple of 32 is 32 itself and the value above 32. Okay. Next question, sub question 3. Write the set of even factors of 124. How to find the even factors of 124? So first to find the factors of 124. So do the prime factorization. 2 times 124, that is 62. 62 divided by 2 is 31. Now we know that 31 is a prime number. So we can write 1 into 124. How to write the factors? 1 into 124, 124. Now next one, it is even number, so divide with 2. So 2 into 62, 124. Now 2 2s are 4, you know. 4 into 31. 2 2s are 4. 4 into 31, 124. So the factors are 1, 2, 4, 31, 62, 124. Okay, 1, 2, 4, 31, 62, 124. Now we want to find even factors. So even factors is 2, 4, 62 and 124. Okay, 2, 4, 62 and 124. So even factors equal to 2, 4, 62 and 124. Okay, these are the even factors. 2, 4, 62, 124. Next question, fifth one. Write the set of prime factors of 3234. We want to write the prime factors. So do the prime factorization. How to do the prime factorization? See, 3234 divided by 2. 1 2s are 2, then here 12, 6 2s are 12, 1 2s are 2, plus 1 is 3, so here 1 14. In 14, 7 times. Again, this is not going on 2 stable because here not any even number. Then check with 3 because 6 plus 1 7, 7 plus 1 8, 8 plus 7 15. 15 is a multiple of 3. So this is going on 3 stable divided by 3. 5 3s are 15 plus 1 16. Here 11. 3 5 3 3s are 9 plus 2 is 11. 27. 9 3s are 27. Now this one is not going on 3 because the sum is not a multiple of 3. 5 39. 5 plus 3 8, 8 plus 9 17. 17 is not a multiple of 3, so it is not going on 3 stable. Now take 7. 7 7s are 49. 4 remainder, then 4 9 49. 7 7s are 49. This is 77 is going on 7 stable. 11 7s are 77, and again by 11 it is 1. So all these numbers are prime numbers, so prime factorization. So it is equal to, the set of prime factors are 2 3 7 11. Okay, 2 3 7 11. Don't write 1 because 1 is not a prime factor. The smallest prime number is 2. Then 3 7 11. 2 3 7 11. Don't repeat this number because in set no need of repetition. Okay. Next, seventh sub question is x such that x square minus 5x minus 6 is equal to 0, which is equal to 2 3. Set 2 3. So here we have to find the value of x square minus 5x minus 6 and check whether it is 0. And x take the value 2 and 3. This x takes the value 2 and 3. So x takes the value 2 and 3. Our equation is x square minus 5x minus 6. Check whether it is 0 or not. So first give value 2 for x. So 2 square minus 5 into 2 minus 6. In the place of x give 2. 2 square 4 minus 5 2s are 10 minus 6. 4 minus 10 is minus 6. Minus 6 minus 6 is minus 12. It is not equal to 0. It is not equal to 0. Again check with 3. So 3 square minus 5 into 3 minus 6. 3 square is 9. 5 3s are 15 minus 6. 9 minus 15 is minus 6. Minus 6 minus 6 is minus 12. This is not equal to 0. Here in our question it is equal to 0. You want to find is x square minus 5x minus 6 equal to 0 when this x take the value 2 and 3. If when x take 2 and 3, this equation is not equal to 0. So no. If it is 0, we can write as it is not 0. Okay. I hope you understand today's class. So let us mark the homework. Exercise 6A. Second question, sub questions 1, 4, 5. And question number 3, sub questions 3, 4, 6. Okay. 3, 4, 6. And from 2, 1, 4, 5. Okay. That's all today's class. Thank you. Have a nice day.